Hello, if you're watching this video, hopefully you have already learned how to label your unit circle in degrees and in radians, keeping in mind that there are 360 degrees to get around the entire circle. So if you divide your unit circle into 8 parts like we have here with our 45-degree angles, 360 divided by 8 gives you 45. So we're just starting at 0 and adding 45 each time. And then in radians, the circumference of a circle is 2 pi r. R is your radius, and because this is a unit circle, it means that our radius is 1. So each of these radii here has a length of 1. So the circumference is 2 pi times 1, which is just 2 pi. This video, we're going to derive each of the coordinates of the 45-degree angles of your unit circle. So starting with right over here, to get from the center of our circle to this coordinate here, we had to go over a length of 1. This is the radius of a length of 1. And we had to go up nothing. So our coordinate at 0 degrees is 1, 0. To get from our center to 90 degrees, we had to go over nothing, up 1. To get to our 180-degree angle, we had to go to the left 1, so we write -1 and up nothing. And then our coordinate at 270, we go over nothing and down 1, so 0, -1. So these are our 4 main coordinates. Great. How do we find these other coordinates, right? So we said we have to go over something and up something, just like normal coordinate plane. So to get from this point to this point, how far over and how far up do we have to go? Now, the shape I just made is a triangle, right? So if I'm going to get a pencil for that. Take my mask off for a second. Okay. If we extend a line from this coordinate point down to our x-axis here, we have made a triangle. And it is a right triangle if we make this line perpendicular to the x-axis. So our angle here is 90 degrees. We know this angle is 45 because that's how we labeled it, right? We divided this into 8 pieces. 360 divided by 8 is 45. So we know this angle here is 45. Which means this angle also has to be 45 degrees. 45, 45, 90 adds up to 180. I don't know if you can see that. So 45 degrees, 45 degrees, 90 degrees adds up to 180. So we need to figure out how long is this length, how long is this length to get to this coordinate point right here. We know that this length of the hypotenuse is 1. We already know that because it's a unit circle. We have to find the other 2 lengths. And we're going to use special right triangles. To do that, we know 45, 45, 90 is a special right triangle. So the hypotenuse has a length of 1. We're not sure what this length is. We're not sure what this length is, but we know it's the same as this. Because 2 of these angles are the same, 45 and 45, this is an isosceles triangle, which means 2 angles are the same, and the sides opposite of those angles are also the same. So these lengths are the same. Now, because this is a right triangle, we can use the Pythagorean theorem, which tells us a squared plus b squared equals c squared, where c is the hypotenuse. So here our hypotenuse is 1. A and b are both x. So we have x squared plus x squared equals 1. We need to solve for x. X squared plus x squared is 2x squared. 1 squared is 1. To get x by itself, we can divide both sides by 2. So we have x squared equals 1/2. To get rid of the squared, we do the inverse of squaring, which is taking the square root. Now, we would get a positive or a negative answer here, but because we're talking about distance, we are just going to use the positive solutions. So x equals the square root of 1 over 2 is the same thing as the square root of 1 divided by the square root of 2. I'm going to continue up here. The square root of 1 is just 1. We can't have a square root in the denominator, so we need to rationalize this denominator. So we need to multiply the square root of 2 by itself. If you multiply the denominator by the square root of 2, you have to multiply the numerator by the square root of 2 as well. Because any number divided by itself is 1, and multiplying by 1 is totally fine. So 1 times the square root of 2 leaves us with just the square root of 2 in our numerator. The square root of 2 times the square root of 2 is the square root of 4, which is just 2 in our denominator. So we just solved for x. X is equal to the square root of 2 over 2. So this length here, to get from here to here, is square root of 2 over 2. This length is also square root of 2 over 2. And this had a length of 1. So this triangle on our unit circle, to get to this coordinate here, we had to go over square root of 2 over 2 and up square root of 2 over 2. So that is our coordinate point at 45 degrees. Now, if we want to find the coordinate point at 135, what happens if we take our triangle and just reflect it over the y-axis? It fits perfectly into this coordinate. Right here's our coordinate. We drop to the x-axis. So how far over and how far up did we have to go? We can kind of see through here. This length, the radius is still 1. This length here, square root of 2 over 2. This length here, square root of 2 over 2. The only difference here is that to get from the center to this point, we have to go left. We have to go in the negative direction here. So the x value of our coordinate would be negative square root of 2 over 2. And then we have to go up. The y value would be positive square root of 2 over 2. To get this coordinate here, we can reflect over the x-axis. So we have from here to here, we go in the negative direction and the negative direction again. So both x and y will be negative at this coordinate point. And then lastly, we can flip it yet again to get to our last point here. To get from the center here, we would have to go over in the positive direction. So our first x value will be positive, then we have to go down, so the y value will be negative. But that completes the coordinates that work for the multiples of 45 degrees on your unit circle. For the ones that are multiples of 30 degrees, see the next